In the last video, we took some time to define what an explicit versus an implicit equation actually was. And we saw here that in number 1, part B, that x squared plus y squared equals 25 was an implicit equation. Now, even though I know that we could solve this to say y equals, note that that would involve taking the square root of both sides of this equation at some point, and therefore would produce not a single equation of that y would equal, but rather two separate equations, one where y was equal to a positive amount and another where y would be equal to a negative. We'll see this more again in just a moment. But what we want to try to do again is to take a look at this implicit equation, this thing that is not a function right now. And we want to go ahead and try to see how we might be able to, I guess in some way, imagine that there are functions kind of hiding within it. So down here, I'm going to ask us to go ahead and actually consider x squared plus y squared is equal to 25. And again, this is just the equation of a circle with radius 5. And I'm going to go ahead and try to just think about what exactly this picture here actually looks like. Now, what I could see is that I know right away that if I have this circle that's going to have a radius of 5, right? So something like this. I can see again right away this is certainly not a function. It does not pass the vertical line test. But what I would be curious about is it possible to see that parts or portions of this particular curve could be viewed as a function if viewed in isolation? So I'll ask the question up here, can we see parts of this curve that could be considered functions on their own? Okay, let's take a look. So I'm going to go ahead here, and keeping this particular curve in mind, I'm going to go ahead and try to just think about sketching maybe different portions of that curve that I could actually state are functions. I'm kind of looking right now for, are there any functions hidden inside of this circle? Well, one thing that might jump out to some of you right away is to say, well, what if I only looked at the top portion of the circle? Would this top portion just by itself be considered a function? And I could say, well, yeah, I mean, by itself, this would perfectly pass the vertical line test, right? So this is kind of a function that's hidden inside of this larger overall picture. But can I find any more hidden functions? Okay, well, yeah, I mean, you might come up with another possibility here really quickly. What about taking a look at the bottom of the circle, right? That in the same way, by itself, passes the vertical line test. It's a portion of the original circle, but while the original circle is not a function, this portion is. Is this the only way that I could get something like this? And, well, the answer here is no. We can actually come up with lots of different ways to imagine portions of this circle that would be considered functions. What about something like this? Right? I could just consider maybe only the first quadrant. Or I could do something kind of interesting and maybe consider, like, if I put like a hole maybe down here, I could consider something like this. This would be a function, kind of like a weird piecewise function that would be coming into play, right? But this would completely work. I could even do all sorts of really weird things where maybe I like take a portion of the circle here and maybe a portion of the circle there. And maybe I take a portion of the circle here and maybe a little portion of the circle right there, right? Like this would be considered a piecewise function, and those are all parts of the circle. So what we can see is that there appears to be several, I'll put this in quotes, hidden functions in this circle, that is, in this implicit equation. And so if there are some kind of hidden functions within there, then what would be great is if I could find a formula for these hidden functions. That is, I found a function formula to graph them. Maybe there's a chance that we could actually find the tangent line slope on maybe these portions of the circle. And we'll see exactly how this is going to work or play itself out in the next example.